Hi, in this lecture I will be focusing on the discrete Fourier transformation. As we have seen in the previous lectures that for the formula for the calculation of the Dtft is following, in which we have W, which is the continuous frequency, and it is this formula which is doing the summation from minus infinity to plus infinity into xn into e minus jwn, and it is giving us the continuous frequency values. From time domain to frequency domain, we have time domain which are the discrete values, and we are in the frequency domain having the continuous values. So it is giving us the continuous values, the DTFT, which cannot be used by the digital computers. So we have to discretize this W, and this W, when discretized, can come in this expression where we have 2 pi by n, where n is the number of samples on which it is to be discretized, and k is a value which is increasing from 0 to n minus 1. So if we put this discretization value of W in this formula of the DTFT, then it will be this formula, which is a formula for the DFT. This is a simple formula of a DFT in which we have also discretized the W, and it is giving us the discrete time values conversion into discrete frequency values conversions, which can be a kind of finite frequency values which can be stored on a computer, and which can be on those values we can do some operations, while the DTFT values are inconvenient to store on the digital computers. Now this is one of the formulas of the DFT. There is another formula which is a less complex formula by using the Twiddle factor, which is W, and this W, when equal to this expression, we can put that value of W over here, which is the Twiddle factor. It can simplifies the formula, and we can have these W values which are in anticipation given to us in the form of the table, and we can have one manual calculation. This is a complicated formula. We can have this formula in a simpler form, and we can quickly calculate it from this formula. So with the help of the Twiddle factor, we can calculate the DFT in a concise way, in a faster way, or we can also use this formula, which is a simple formula for the calculation of the DFT, and we use the DFT values in the digital computers for further processing. Now for the computation of the DFT, we can use some softwares of computers or some digital calculators, or we can do some manual calculation, which is can be demonstrated in this way. Like we have this formula, which is the simple formula for the calculation of the DFT. From the time discrete values, we calculate the discrete frequency values. In this formula, we first open this summation, and once this summation is open, then we can this summation is being opened by putting the values of n in this formula, and once this summation is open, we can have a big equation, and in that big equation we can put different values of k from 0 towards increasing the values. So we can get the xk values, and we can calculate the manual calculation. Now we can use this DFT formula to calculate our samples. Like we have 4-point sample. This is arrow is indicating the 0-point value, and this is 1, 2 and 3-point values. So and afterwards, when we get xk, we put xk from 0 to 3 to get the relevant number of xk values. So we have put x0 over here, we got these values. We put x1 over here, we got these values, and we have done the simplifications. For the calculation of ej theta, we use this formula. This is a kind of Euler formula which is doing the conversion of the exponential values into the trigonometric values, and which creates a simplification in calculation of values. Then we put xk2, then xk3, and we got these 4 values. So that's how we have used the simple formula of the DFT, and we firstly open this summation, and afterwards we once get opened this summation, we put the values of k from 0 to 3 and we get xk values, which are the frequency discrete values for the xn values. Now we have previously done it for the 4-point values, and if we have 8-point values, 8-point samples from 0 to 7, then we can use the same procedure. We use the formula, we open that formula first, we open that summation by putting the n values over here, then we put the k values from 0 to 7 and we calculate our xk values, which is a too much complex process and requires too much calculations and too much complexities and too much time consumption. So in order to avoid from that, we have a slightly faster method which we have also studied previously, the Twiddle factor method, in which we have the w values which are w0 to 7, or these are the values for the 4-point and the 8-point DFT samples, which we use in our formula to directly put those values and to calculate the DFT in a slightly faster way. Let's have an example of that. Like we have xn for a 4-point samples, 0 to 1, 2, 3 point sample values. We have a 4-point sample and we need to calculate the xk, the DFT, with the help of the Twiddle factor method. Over here we can see that this is the formula for the Twiddle factor, and we have opened the summation. Firstly we got this equation, and then because this equation was opened due to putting the values of n, which is from 0 to 3, and we have opened this summation to get this equation number 1, and afterwards we get because this is the simple formula, we have this equation, which is the second equation, which arises when we open this summation. So we have to calculate the DFT of this 4-point sample with the help of Twiddle factor method. This is the formula. We open the summation, we got this equation, and now we have to put the values of k, which are from 0 to 3, and we put their values, we get these equations, and we with the help of the table we put these values and we get the answer, and we get the DFT in a very faster way, which can be verified with the previous example values, which got the same values of xk, but it requires a too much cumbersome and the large process because of the simple formula calculations. But with this Twiddle factor method and with the help of this table, we are in a very faster way doing the calculation of the DFT in a very faster way. So similarly for the 8-point sample, we use the same Twiddle factor formula. We open the summation and then we put the values of k from 0 to 7, and then we can calculate the same values in a very faster way. Now, and there is another thing we have to calculate the inverse discrete Fourier transformation. And for the inverse discrete Fourier transformation, in this example we have about 4 frequency values, and we have this formula for the inverse discrete Fourier transformation. We put the values of k from 0 to 3 over here, and then we open this summation. First we open this summation and put the values of k, and it is this kind of thing, and then we have to put different values of n, and we uh, put those values from 0 to 3 to get the xn values in a from the simple Dfd formula. So this was so far we have understood how we can calculate the DFT with the help of simple formula and Twiddle factor formula, and how we have to calculate the IDFT from the simple formula. Now we will be moving towards how to do the calculation of the convolution, because for the purpose of doing the convolution calculation we use these transformations, and we do the convolution either by the direct method or the Z transformation method or the DTFT method or the DFT method. So the direct convolution calculation method is elaborated over here, and it is beyond the scope of this lecture. We will be focusing on the transformation methods, these three transformation methods by which we can calculate the convolution. And so firstly we can focus on the Z transformation method. We know that convolution in the frequency domain is the multiplication of the input with its impulse response, and which will give us the output. So this relation can be used to calculate the convolution. For that we have to first calculate the xz and then hz. And how to calculate xz? We have this xn from 0 1 2 3 point sample, and from 0 1 this is impulse response. We will calculate xz from this and hz from this. For xz we put the values of xn, and over here from 0 to 2, because we have 3 point samples, and we open this summation, and we have this readings, because this is the formula for the Z transformation, and we put the values of n over here and we calculate the xz over here. Similarly, we put the values of hn over here, 2 point sample, and we calculate the hz, and we multiply these two values, and we uh, 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 get the yz and yz over here. And then we can have this by looking at these values. We can see this is the present value, and the negative values of z indicate the future values, while the positive indicate the past values. So these are the values which are at the 0 point we have 2, and then 5 8 3 the other values. Now the other method to do the convolution is the Dtft method, where we have the same method as in the Z transformation, but we only replacing the Z with W over here, and the rest of the procedure is nearly almost same, just we have over here Z is replaced by EJW over here, and the rest of the procedure is the same. We uh, calculate XW from XN and HW from HN by these formulas. We multiply those with each other, and then we can carefully see this relation, and we can analyze, and we can see that how we can calculate yn. This is the coefficients of these terms are at the 0 point, the future values 5 8 and 3. The coefficients represent the yn values. So those were the two methods by which we can calculate the convolution. There are also other two methods. One is the Dfd method and other is the FFT method, which we will see. In the Dfd method, it is a bit complex. In this method we calculate yk is equal to xk multiply by hk, and for the xn we have to do zero padding, and for the hn we also have to do the zero padding, because it is either calculated for a 4 point 8 point, and it is in those ways we can calculate the DFT. And then with the help of xn we calculate the xk with the help of the Twiddle factor formula, which we have already understood, and open the n values to get this formula, and then putting the values of k from 0 to 3 to get the xk values. Similarly, for the h we have also done such kind of formula, and we have put the values of h n and open the summation, and then put the values of hk 0 to 3, and we have got the values of xk from 0 to 3 and hk from 0 to 3, and then we have done their multiplication to get the values of y from 0 to 3, and then we have a formula of the inverse discrete Fourier transformation in the Twiddle factor kind of formula, and we use these values, and we do their inverse discrete Fourier transformation. Over here we have four values over here, so 0 to 3, and then we have opened the summation, and we have four values, and then we have put the values of n from 0 to 3, and we got our values of yn. Another method for the calculation of the convolution is the fast Fourier transformation butterfly method. In this method we have drawn four lines, and x0 x1 x2 x3 values put over here, and we have Twiddle factor values W0, W2, W0, W2, W0, 1, 2, 3 put over here from the table previous from this table, the table of the Twiddle factor values, from where we got these values. We put those values over there in the convolution calculations for the fast Fourier transformation way of calculating the convolution. So we have put the Twiddle factor values 0, 2, 0, 2, 0, 1, 2, 3, and the x values x0, x1, x2, x3, and then we have proceeded from here. This value is multiplied with the Twiddle factor and addition in this value, and similarly the bottom values multiplying by the Twiddle factor and added in the upper values, and then this line goes towards right hand side. And uh, uh, in this way we have done for the xn values, for the h values, and then once we get the values of x k and hk on the right hand side, with the help of the FFT methods we can do their multiplications to get the yk values from 0 to 3, and then we apply the Dfd butterfly as well, which is another kind of butterfly in which we have 1 over 4 multiplied over here, and the negative the Twiddle factor odd values are changed in sign, and similar kind of operation is performed in which we have to calculate the FFT, and afterwards we will be getting this kind of yn. So if we can see that this is y values, we have taken these y values by multiplying the x values with hk values. Now we will be using the inverse IFFT, in which we will be putting, we would be having these values of y0, y2, y1, y3 over here, and W0, W2, W0, W2, and W0, 1, 2, 3, and the 1 and the 3 values will be changed in sign of the Twiddle factor, and 1 over 4 multiply at the last, and similar calculation, and with this calculation we are able to calculate the yn. Thank you very much.